Bismillahirrahmanirrahim. Welcome back to my channel. Another demonstration of cognitive radio ability. So I was working with GNU Radio, and there is an out of tree module which is known as GR Inspector. You can simply download this and go to their GitHub page and you can compile it. So it comes like something like this: GR Inspector. I already made a video on it, but this one is going to be something that I would like to discuss. I think the last video that I made on GR Inspector with respect to cognitive radio application was actually to detect signal. So in this video, we're going to detect signal, we're going to extract the signal, we're going to separate the signal, and we'll try to demodulate the signal. So GR Inspector is an out of tree module that allows me to do an analysis, conditioning with respect to a signal detector, extractor, GUI, and you have a GUI inspector GUI. So these are the blocks. When you compile it, go to their GitHub page and you can just simply download this, and then you can compile it yourself, and it will become part of your repository in your GNU Radio. Or even you can download a newer version of GNU Radio, and that is already part of this of your the GR Inspector is already part of new GNU Radio. I already made a video on it. You can go ahead and look at that video as well. So the block is quite simple. I haven't done anything fancy. The only thing that I have, so I'm using an RTLSDR source. You cannot see it, but my RTLSDR dongle is connected to my laptop. And the only parameter that is being controlled here is actually a frequency parameter. And this frequency has a range from 90 megahertz all the way up to 110 megahertz, which is generally the FM range, worldwide range. And default frequency is 101.8. I was experimenting with this. So 101.8, I could not get any signal. But let me just change this to 106.2. This is where I was actually seeing, because I'm right now indoor and I'm using a crappy antenna that comes with my RTLSDR dongle. So that's why I was not getting a proper result, but you would see why I was saying this. Then is going into a signal detector block. This is the main block. So I haven't changed anything in the parameter. The only thing that I was manipulating or playing around is the threshold. Based on the threshold, it will start actually getting the signal in. Based on a certain threshold value that my GUI inspector sync that you would see based on that threshold. So basically this is in dB. So you can set this threshold to be very low and it will start detecting lower signal, but will it be able to extract that? That's a different story, because you would have also some noise signal as well, and that would, like, it will continue hop around based on the different thresholds. So I'm going to leave this as -50, and then I'll tell you why. And all the rest of the values are exactly the same. Next is going into a GUI inspector block. This is where you're going to actually see the actual signal, and it's mapping out into a block called signal separator. I haven't done anything. I'm just using the default value. You can use a transition width and cutoff frequency to be 0.1. You can choose it to anything. I'm just leaving it as default value. So basically, you will detect the signal based on the threshold value. After that, you're going to visualize that signal, and this will go into a signal separator that will separate the signal based on the transition bandwidth and cutoff. And then out of those signal separator, you're going to extract a particular signal. That particular signal, all the rest of the values are default. Yes, the only thing that is actually output sample rate. I have chosen this to be 96,000 kilo samples, and this is the same rate that I have chosen in my quadrature rate. So quadrature rate is 96,000, and audio decimation divided by 2, it will give me 48 kilohertz. This is what I want to hear on my audio sync. That's it. The only thing that I have changed is actually chosen this to be 96,000. So I can have an audio sync rate to be 48 kilohertz, because this is the speaker default speaker that is you get 48 kilohertz of sample rate. That's why my audio decimation is 2, because 96,000 divided by 2 would give me 48 kilohertz. And this is the block. So in the entire block, what we're doing, based on the threshold value, we're trying to detect a signal. We're trying to separate the signal. We're trying to extract the signal, and that particular signal, I want to receive that signal, or I want to demodulate the signal, because the frequency that we're looking at, these are the frequencies of FM. So we're basically trying to, out of many signal, automatically trying to detect a signal based on the threshold value, trying to separate the signal, extract it, and try to demodulate the signal using a wideband FM receive block. And we want to hear that signal as well. And this is the GUI time sync, so you can also see what's going on your time sync block. So the flow graph is quite simple. Right now I have connected my RTL SDR dongle, and it comes with whatever the crappy antenna that I have, plus I'm also indoors. So let's quickly look at it. Let me run this flow graph. All right. I don't know if you can hear it, but you can, in that noise signal, you can hear volume. There's some music in the background. The reason I have chosen 106.2, because all the rest of the places I wasn't getting anything, because of indoor, because the kind of an antenna that I'm using. But you can clearly see that you will be able to demodulate the signal based on the threshold that I have set, which was negative 50 dB. Now this is all manual now. All right, and let me just select this to go to automatically detect that. When you do it automatically, remember your threshold value is minus 50. Let me actually, your actual value is negative 50. So any signal that would have a threshold value of negative 50, it will try to catch that signal and try to demodulate that particular signal. So there will be a lot of noise plus your signal. So let's see what happens. So when I move this from manual, so let me keep the voice on. Let me turn on the voice. You can still hear some signal. And by just looking at a signal, you can see this is somewhere around negative 20 dB. So this particular signal, which actually compilation of a lot of different transmission that is taking place in adjacent bands, you can hear the noise and things like that. And you are somewhere at around negative 20 dB. Now, when I select this to do it automatically, now it's hard for the demodulator to work on this, because there's a lot of signals that will have negative 50. So it's basically just like in cognitive radio, it's hopping from one frequency to another frequency and going back and forth. And it will try to extract that signal, at the same time try to demodulate signal. While trying to demodulate that signal, you also have another signal that is coming in. So because it's hopping from different places. So you can, I hope you're getting it what I'm trying to say, because you have a threshold negative 50. So negative 50 is somewhere around here, because this is 40, negative 40, this is negative 60. So this is negative 50. So you might have different bands that might be operating that my antenna is not properly receiving. Plus you have this signal that is negative 20. So anything that is above greater than negative 50, you are getting it. But you might have noise and other signal like that's why my automatic signal extractor having a hard time, but you can still see that noise plus some squeaky sound based on this. And I try to play around with that. You can go ahead and hear, and let's go to a threshold. Let's say you're getting a threshold. I can see my maximum signal is negative 20. So let's apply this, because my signal, so now I've changed my threshold to negative 20. Manually, I can still hear my signal at negative 20, but when I do it automatically, you would see that negative 20 is not a proper threshold, because sometime it will detect that signal, sometime it's not detecting that signal, because the signal is continuously changing. So let's do something else. Let's increase our threshold to be a little bit smaller, like let's go like negative 25 or something like that. So when I go to negative 25, let's see what happens. And let me hit play. So manually is still working. You can still hear the music coming in, even though a lot of distortion is there. But let's try it. See, as soon as I have changed my threshold, look, I also focus on this as well. Because the signal is so much fluctuating, it's hard for it to actually capture one particular signal and hold on to it and demodulate this signal in, while you have some other signal that is also coming in as well. So the idea was of this particular demo was, because if you have a right antenna, and if you have a right channel spacing, you will be able to, of course this is an audio FM signal, but when you have just only signal that you are interested in, you can easily visualize multiple signals simultaneously, and then you can pick up those signals and individually demodulate them. So this example was actually to do live FM demodulation using both automatically and manually. So I hope this flow graph might help you in whatever that you want to do. This is just to show you that indeed you can use signal extractor and separator blocks. Of course, you can tweak around with different values and see what result you will get. But this is what I wanted to share with you guys. So I hope you like this small tutorial. And if you have any questions, just leave it in a comment section. And don't forget to like and subscribe to my channel. And thanks for watching.